Hi, everyone. This is Daniel, and today I want to talk one of the great professor and scientists in the field of psychology and rehabilitation medicine, Professor Mark Jensen, Vice Chair Research in Rehabilitation Medicine in the University of Washington, and Professor of Rehabilitation Medicine in the University of Washington. Hi, Professor Jensen. I hope you are well.
I am. Thank you, Daniel. It's good to see you.
At the beginning of our interview, could you please introduce yourself and your research interest?
Sure. Yes, I'm a clinical psychologist by training who works in the Department of Rehabilitation Medicine. And my entire career really has been devoted to understanding pain. And in particular, the psychological factors that contribute to pain and how we can develop treatments for pain based on that understanding. So the bulk of my research studies has really been looking at studying the efficacy and mechanisms underlying psychological treatments of pain.
Great.
That includes all treatments, cognitive behavior therapy, hypnosis, mindfulness meditation. I'm starting to look at music as treatment. So I'm just very interested in how the brain creates pain and how we can use that understanding to help people gain control over their pain and suffering.
Great. It seems your research area very close to neuroscience. What is the relationship your research area and between your research area and neuroscience?
Yeah. So my focus is on pain. And pain is an experience that is created by the brain. So if you want to change pain, you must understand how the brain creates the experience of pain. And from a neurophysiological perspective, and how the treatments that we develop can impact that neurophysiological function so that people can feel more comfortable. So it's directly linked because the experience of pain is so closely linked to neuroscience.
Great, amazing. Sometimes I hear that hypnosis is pseudoscience. I always challenge with these individuals. What is your opinion about hypnosis? Is there any clinical application for hypnosis?
Right. So I guess my response would be, it's funny to call anything a pseudoscience, because if something is happening, you want to study it from a scientific perspective. So hypnosis is not science or not science. It's a thing that you study. And you can study it from different perspectives, including from the perspective of rigorous science. Now, when we do study the effects of hypnosis using rigorous controlled studies, including randomized controlled studies, the evidence is clear that when people are taught how to use self-hypnosis, they report decreases in pain. They report that they sleep better. They report that they feel in a better mood and they feel more in control over pain. So there's no doubt that training people in the use of self-hypnosis is effective. Now, the interesting question is why? What is it about hypnosis that makes it work? And one answer could be, well, it's a type of placebo, right? You just change how people think about their expectancies about their pain. And hypnosis is just a placebo. Well, when we compare hypnosis to placebo treatments, hypnosis is more effective. So it can't be placebo, right? Now, of course, every treatment has a placebo component. So placebos work. But the question is hypnosis better than placebo, more effective? And the answer is yes. So then we go, well, why? What is it about hypnosis that makes it more effective? And we've been studying the effects of hypnotic inductions and hypnotic suggestions on brain activity. And we find that hypnosis, when people do the thing that we call hypnosis, their brain changes in systematic ways that are very, very interesting, and in ways consistent with a brain reporting less pain. So just for example, if you invite somebody to dip their hand in painfully hot water and then give them the hypnotic suggestion that it bothers them less, even if they can feel the pain, you see a direct impact in the anterior cingulate cortex, a decrease in activity, but not in the sensory cortex. You then do that study again, but give them a hypnotic suggestion that the pain intensity decreases. You see changes in the sensory cortex, but not the anterior cingulate cortex. In other words, a person is able to respond to hypnotic suggestions specific to those suggestions and specific to the parts of the brain involved in processing of that. We've compared hypnosis to meditation, and we see that when people do what we call hypnosis, the brain changes in a very systematic way. We see an increase in very slow wave activities, low alpha and high theta activity, and theta activity in general. And with meditation, you see more of changes in alpha activity. So hypnosis is very specific. It's not general. And hypnosis is very simple. You simply invite someone to pay very close attention to one thing. And when people do that, the brain changes. And when the brain changes in that way, people are more able to focus and make changes in their experience. The brain is more neuroplastic in hypnotic states. Now you see hypnosis on the stage and it looks crazy. And what you see on the stage is not clinical hypnosis. So when people say, it's pseudoscience, it doesn't make sense, that's because they're thinking what they see on the stage and they're thinking what they see in the movies. That is not hypnosis. That is not what we're studying. We're studying something very simple. Invite someone to focus their attention very intently and then give them a suggestion. And when you do that, people respond.
Thank you. Hypnosis is one of the topics that always fascinated me. As you know, neuroscience has very advanced in recent years. How do you look at the future of the effects of neuroscience on hypnosis?
Yeah, so for the past decade, neuroscientists have been studying the effects of many psychological treatments on neurophysiological function. That includes structure and includes functional activity. And so, we've been using PET scans, fMRI, structural fMRI, EEG, and the results have been fascinating. I've summarized some of them very, very briefly, but I fully anticipate that in the future, we will continue on this path. And an important part of the path, I think, are to understand how the different treatments we provide that may look similar do have different effects on brain. And also understanding how people's baseline brain activities predicts how they respond to different treatments. So, for example, if you measured the EEG activity in everyone who's watching this right now, we would see a variety of baseline EEG activity. Some people will have baseline more theta than others. Others will have more beta. Others will have more gamma. We have different baseline profiles of our brains. And the evidence from our studies is that baseline profile predicts which treatment you will respond to. So people who have more theta activity like hypnosis more, and they respond to it more. People who have more beta activity, active brains, engaged brains, they like cognitive therapy. They don't like the hypnosis stuff. And so we should not be arguing hypnosis is better than everything else, or cognitive therapy is better than everything else. What we should be understanding is, what is the treatment that's going to help this person that they're going to like the most? And we can do that by understanding how baseline brain activity, baseline brain structure predicts response to these different treatments. And then we can match people to the treatments that they use.
Thank you very much. As my last question, what is your advice for young Iranian researchers?
I guess I've been fairly successful because very early on, I decided that to succeed, I needed to write and publish. So my recommendation, and when I started, I couldn't write very well at all. But writing is a skill that gets better with practice, like every other skill. So I urge Iranian researchers or young researchers everywhere in the world, write. Start writing a paper now. Plan a paper. Write it, submit it. It will get rejected, and don't worry about it, because you will get better with practice. The first chapter that I wrote has never seen the light of day. It was rejected, and I never went back. But eventually, my papers started getting accepted after many revisions. And over time, you just get better and better and better. So write papers. Oh, and I got very good advice from my first mentor, which was, at any one time, you should be collecting data from a study. And while those data are being collected, you should be analyzing data from another study. And while you're analyzing those data, you should be writing up the results of analyses of another study. And then you should have a paper being reviewed by somebody and a paper in press. And if you spend too much time only collecting data, you never get anything published. And if you spend too much time analyzing and reanalyzing, you never get the paper done. So think about having something in each of those bins, but always be writing a paper. And if you can find a mentor who can help you learn the process of writing and research, work with them closely and learn from them. So I personally have had some of the best mentors in the world who are very, very supportive, and they taught me how to write. I would give them text and they would completely edit it. But over time, there were less and less edits. And now with my students, they give me text, I tell them to write, and then I completely change it. But over time, they get better. So the one word is write.
Very good. Dear Professor Jensen, thank you very, very much for accepting my invitation. I appreciate you.
Okay, thank you, Daniel. It's good to see you.
Thank you. Goodbye.
Take care.